Yeah. Hi students. This is Madhurawala. In the previous class, I explained you about linear systems, and I solved a problem. Take an example. Okay. So I proved the given system is linear. So how we say that the given system is linear means if it satisfies both the principles of homogeneity and superposition, then we can say that signal is a linear signal. So in the last class we discussed about these linear systems, and at the end I taken an example of a system as y of t equal to x of t square. So here the system is represented by the equation y of t equal to x of t square, y of t equal to x of t square. Okay, and I solved all this and I proved it is satisfying both the principles of homogeneity and superposition. That is, here the weighted sum of outputs is equal to the output due to weighted sum of inputs, or simply output due to weighted sum of inputs is same as weighted sum of outputs, then we can say the system is linear. So I discussed up to this point in the previous class. Now in this class I am going to teach you non-linear systems. So non-linear system, as I said, a system is said to be the linear system if it satisfies the principles of homogeneity and superposition. So in the same way, if I want to say a system is a non-linear system, if I want to say system is a non-linear system if it does not obey the principle of superposition and homogeneity. If a system does not obey the principle of homogeneity and superposition, then that system may be called as non-linear system. I already explained you this in the previous slides. Okay, now I explained about non-linear systems. Now consider two systems. As we considered for linear. In the same way, here also I am considering two systems with inputs as x1 of t, x2 of t, with inputs as x1 of t and x2 of t. Okay, next, and outputs as y1 of t and y2 of t respectively. So here I am also again considering two systems with inputs x1 of t and x2 of t and outputs y1 of t and y2 of t respectively. So in the previous class also I explained you this one. So here they will consider a system with inputs x1 of t, output y1 of t. Here also they will consider a system with input x2 of t and output y2 of t. See, so like this we will consider two systems with input x1 of t and x2 of t and output y1 of t and y1. That is, y1 of t is the output for input x1 of t and y2 of t is the output for the input x2 of t. Okay, our system. Now if the systems are not satisfying superposition and homogeneity principles, gives non-linear systems. So if the system does not obey the principles of this homogeneity and superposition, then we can say that system is a non-linear system. So in the not satisfying superposition and homogeneity principles gives the non-linear system. If this system does not follow the homogeneity and superposition principles, then we can say that this system is non-linear system. Okay. Now the condition is same. There it has to obey. That is, their output due to the weighted sum of inputs is equal to the weighted sum of outputs. So for non-linear, what we can say? Simply output due to the weighted sum of inputs. Output due to the weighted sum of inputs is not equal to the weighted sum of output. Output due to weighted sum of inputs. Output due to weighted sum of inputs is not equal to the weighted sum of outputs. Okay, output due to, this is the output due to weighted sum of inputs is not equal to the weighted sum of outputs. So this is sentence formation. Now we will see the mathematical equation for that one. So here see, weighted sum of inputs x1 of t and x2 of t are the inputs, and a1 a2 are the weights, that is they are multiplied constants. Okay, now weighted sum of inputs means a1 x1 of t plus a2 x2 of t. This is the weighted sum of inputs. Now outputs due to, that is output due to the signal. So output is due to that signal will be represented as transformation of, transformed form of, transformed version of. For that transformed version of weighted sum of input, that is output due to weighted sum of inputs is not equal to what you have to get? Not equal to what you have to get? The output due to the weighted sum of inputs is not equal to weighted sum of outputs. So these are the outputs, these are the weights, and these are some weighted sum of outputs. So how will you get? Simply here I have to write, separate this transformed version of a1 x1 of t plus transformed version of a2 x2 of t. Take a1 as outside, a1 transformed version of x1 of t plus a2 transformed version of x2 of t. So if you solve like this, if this one, the LHS side is not equal to the RHS side, then we can say that this system is a non-linear system. For linear, these two will be equal. For non-linear, these two will be not equal. Simple logic. Okay. Now, so there I explained the concept of linear system by considering an example. Here also I am explaining the concept of a non-linear system by taking an example. So here I am taking an example a system like y of t equal to x square of t. There I have taken y of t equal to x of t square. So for linear systems I have taken y of t equal to x of t square. For non-linear system I am taking the example of the system as y of t equal to x square of t. So here I have considered the system with the equation y of, that is output of the system, y of t will be equal to x square of t. The procedure is same. First what I have to find out? Weighted sum of outputs, and what I have to find out? Output due to the weighted sum of inputs. First I have to find out weighted sum of outputs, and then I have to find out output due to the weighted sum of inputs. If these both are equal, then I can say that is a linear system. If these both are not equal, then I can say that is a non-linear system. I am explaining about the non-linear system. So for this system, for this given system, the output due to weighted sum of inputs for this system, the output due to weighted sum of inputs should not be equal to weighted sum of outputs. So we have to prove that one. Then only we can say this is a non-linear system. So we will see the method for that one. Okay, first, for a general system with input signal as x of t and output signal as y of t, input signal as x of t and output signal as y of t, mathematically we can express that one as transformed version of x of t will be equal to y of t. So this is the general mathematical expression for a system with input x of t and output y of t. Okay, so in the same way, this y of t, I am representing as y of t equal to transformed version of x of t. Y of t equal to transformed version of x of t. According to the given problem, that value will be equal to x square of t. So generally y of t can be written as transformed version of x of t. As by the given problem, that y of t value or the transformed version of x of t value will be equal to x square of t. First thing. Now this is for the input x of t. Let us consider for input x1 of t. So to satisfy the superposition I need two signals. So I am taking the input x1 of t. In place of x of t I am taking x1 of t. For the input x1 of t, what will be the output y1 of t? So we know the y of t. Now I need the y1 of t. So y1 of t will be equal to transformed version of x1 of t, which will be equal to x1 square of t. Simple. So in place of y, I will replace it with y1. In place of x, I will replace it with x1, because this is the signal for this is the system for input signal as x of t and output signal as y of t. So for the same system, I am taking the input as x1 of t, and for that the output will be y1 of t. So y1 of t equal to transformed version of x1 of t, that will be equal to x1 square of t. The same way, so if we go for the input, if I change the input for the input x2 of t, so I know the system. So system input is x of t. For that I will get an output y of t, which is nothing but a transformed version. So whose value they are given as x square of t. So here in the first case I get taken x1 of t. Now output is y1 of t. The equation is x1 square of t. The second case I am taking another input x2 of t. So the output will be y2 of t, and the equation will be x2 square of t. So for the input x2 of t, the output y2 of t will be equal to transformed version of x2 of t, which will be equal to x2 square of t. x2 square of t. Now weighted sum of outputs. I will go for weighted sum of output, because this is the output for x1 of t, this is the output for x2 of t. So I am going for weighted sum of outputs. So I know the two outputs. Weighted sum means weights. So we have to multiply these outputs with some constant. Here I am taking the constants as a1 and a2. So a1 is multiplied to y1 of t, and a2 is multiplied to y2 of t. And if we add those two, that will become weighted sum of outputs. First I have to take the outputs, and I have to multiply each output with some constant, and then I have to add those two, then I will get the weighted sum of outputs. So the weighted sum of output will be written as a into y1 of t plus a1 into y1 of t plus a2 into y2 of t. Okay, a1 into y1 of t plus a1 into y1 of t plus a2 into y2 of t. So a1, a2 are constant. There is no need to take a1 and a2. We can take any letter, a, b, m, n, whatever it may be. So they are nothing but constants. So here I am taking a1, a2 as constants, because there is 1 and 2. For simply understanding, I go on for a1, a2. Okay. So a1 y1 of t plus a2 y2 of t will be equal to what? a1 as this. What is the value of y1 of t? The value of y1 of t is x1 square of t. So a1 x1 square of t plus I kept a2 as this. And what is the value of y2 of t? y2 of t value is x2 square of t. So the weighted sum of outputs is a1 y1 of t plus a2 y2 of t will be equal to a1 x1 square of t plus a2 x2 square of t. Okay, so this is the weighted sum of outputs. Now what I have to calculate? I have to calculate output due to weighted sum of inputs. Output due to weighted sum of inputs. First I need the weighted sum of inputs. So weighted sum of inputs is a1 x1 of t plus a2 x2 of t is the weighted sum of inputs. For that I need the output. So output is nothing but transformed version of a1 x1 of t plus a2 x2 of t. So output due to the weighted sum of inputs. So this is the weighted sum of inputs. a1 x1 of t plus a2 x2 of t is the weighted sum of inputs. Now I have to go for output due to this one. So how can I get the output due to this one? By taking the transformed version of this. So the transformed version of this weighted sum of inputs will give the output. The transformed version of weighted sum of inputs will give the output. So that is the output due to weighted sum of inputs. The output due to weighted sum of inputs. So the output due to weighted sum of inputs, transformed version of a1 x1 of t plus a2 x2 of t will be equal to see this one. So this is the input. What is the function? Actually the function is y of t equal to x square of t. Y of t equal to x square of t. So the signal is squared. Actually here the signal is squared. Now here the weighted sum of the input is this one. So this is our complete signal. Now I need the output of this complete signal. So how can I get the output? By squaring the input signal. So here the function is what is the system will do? The system will square the given input signal. The system will square that is, it will multiply the signal with the same signal again. Okay, that is, if we give x of t, again it is multiplied with another x of t into x of t, x square of t. So the function of the system, what the system will do? The system will square the input signal whatever applied to it. If it is applied x of t, it will be squared and given as x square of t. If it is x1 of t, that will be squared. If it is x2 of t, that will be squared. Here the input is weighted sum of the inputs, that is a1 x1 of t plus a2 x2 of t. So this complete a1 x1 of t plus a2 x2 of t, this complete signal is given as input to the system. So this is the important point. This is the important point. If you understood that point, then the whole concept is very easy. So here the input is a1 x1 of t plus a2 x2 of t. So concentrate on this point. So a1 x1 of t plus a2 x2 of t. What the system will do? System will square the value, that is the input signal is multiplied with itself again. So this is the input signal. So that value is multiplied with the same value again. So we have to go for x into x square, y into y square, z into z square. So here the signal is a1 x1 of t plus a2 x2 of t. So what the system will do? It will multiply the signal with input signal with the same value. So a1 x1 of t plus a2 x2 of t is multiplied with a1 x1 of t plus a2 x2 of t, because the function of the system is it will square the input signal. It will square the input signal. So here the input signal is this one. So output will be square of that signal. Square of that signal. Square of the signal a1 x1 of t plus a2 x2 of t whole square. a1 x1 of t plus a2 x2 of t whole square. So this is the square of the input signal. So I hope you understand clearly how we get this. Simply here, if there is output due to the weighted sum of inputs. So for this I need the output. For this I need the output. So the system function is squaring of the signal that I have given to it. So here the signal is this one, a1 x1 of t plus a2 x2 of t. So I squared it. Now if you solve this, what becomes a1 square x1 square of t plus a2 square x2 square of t plus 2a1 a2 x1 of t. So it is a large one if we apply the formula a plus b whole square. Simply there is no need to do anything. Now see, the weighted sum of outputs is this one. The weighted sum of outputs is this one, and the output due to the weighted sum of input is this one. Now these two are not equal. These two are not equal because this is a1 x1 square of t plus a2 x2 square of t, but it is a1 x1 of t plus a2 x2 of t whole square. Let's take this is a square plus b square. This is a plus b whole square. So a square plus b square is not equal to a plus b whole square. A square plus b square is not equal to a plus b whole square. So here the weighted sum of outputs is not equal to the output due to weighted sum of inputs, or output due to weighted sum of inputs is not equal to the weighted sum of outputs. Hence we can say this system is non-linear. So we can say here the system is said to be non-linear as it does not follow the principle of homogeneity and superposition. Okay, so it is not obeying the principle of homogeneity and superposition. If it is obey the principle of homogeneity and superposition, these two will be same. Here the two values are different. So here the output due to the weighted sum of inputs is not same as the weighted sum of outputs. That is, it is not obeying the principle of homogeneity and superposition. Hence we can say that this system is a non-linear system. So the system is said to be non-linear system. So this is the way how to prove whether the system is linear or non-linear. So here I have taken this as an example for non-linear. So I proved this given system is a non-linear system. The given system is a non-linear system. Yesterday I proved I taken as example for a system as y of t equal to x of t square, and I solve I go on through the procedure, and finally I proved that the output see here system there the output due to weighted sum of inputs, the output due to weighted sum of inputs is equal to the weighted sum of outputs. So both are same, hence that we consider as a linear. Whereas in this case the output due to the weighted sum of inputs is not equal to the weighted sum of outputs. That is this one, that is this one and this one does not equal. So these two are not equal. Hence we can consider this system as a non-linear system. Okay. Non-linear system. Clear. Next. So up to now we have considered only x of t and y of t, x1 of t, y1 of t, x2 of t, y2 of t. So here x of t and y2 of t represents continuous time signals. Continuous time signals. So there the independent variable time t is represented for continuous time signals. So in the first class I explained the continuous time signal is represented with x of t and the discrete time signal is represented with x of n. So up to now we discussed about linear and non-linear systems with respect to continuous time signals. So in the previous class I explained the concept is same for continuous time signals as well as discrete time signals. So the only change is in place of x of t we have to write x of n. In place of x of t we have to write x of n. In place of y of t we have to write y of n. That is replace t with n. Then we can get the equations for linear and non-linear systems with respect to discrete time. With respect to discrete time. So I am explaining this one. Linear and non-linear systems with respect to discrete time. I am explaining this. So consider a system as an input. So consider a system with input as x of n. For continuous time signal it is x of t. For discrete it is x of n. And the system has output as y of n, because so y of n. This is for y of n, yeah, y of n, that is the output for discrete. For continuous it is y of t. Simple. There I have written x of t as an input and y of t as an output. Here I am writing x of n as an input to the system and y of n as output to the system. So if x1 of n is the input, then the output of the system is y1 of n. If x1 of n is the input of the system, then the output of the system is y1 of n. If x2 of n is the input of the system, then the output of the system is y2 of n. y2 of n. Now, if the system obeys the principle of homogeneity and superposition, if the system obeys the principle of homogeneity and superposition, then we can say that the system is a linear system. Otherwise, we can say the system is non-linear. That means if does not obey the principle of superposition and homogeneity, then we can say this system is a non-linear system. So that can be represented with a mathematical equation like this. So mathematical equation. So then if the input of the system is a1 x1 of n plus a2 x2 of n, that is weighted sum of the inputs is given as an input to the system, input signal to the system. So here if x of n is the input, y of n is the output. If x1 of n is the input, y1 of n is the output. If x2 of n is the input, y2 of n is the output. Now here the input of the system is a1 x1 of n, a2 x2 of n, a1 x1 of n plus a2 x2. Simply, so this is nothing but weighted sum of inputs. Weighted sum of inputs. If the system gives the output as a1 y1 of n plus a2 y2 of n. For an input a1 x1 of n plus a2 x2 of n, if the output is a1 y1 of n plus a2 y2 of n, then we can say the system is following the principles of superposition and homogeneity, and that system is a linear system. If for the input a1 x1 of n plus a2 x2 of n, if the system is giving any output other than this one, then we can say that system is not following the principle of homogeneity and superposition, and we can say that system as a non-linear system. Okay, I hope you are all clear with this. Now, so we can simply write it in mathematical form also. So output due to weighted sum of inputs, output due to this one, that is transformed version of a1 x1 of n plus a2 x2 of n. We have to find out the transformed version of this one. So if that will be equal to a1 y1 of n plus a2 y2 of n. So that is the weighted sum of outputs. This is the output due to weighted sum of inputs, and these are the weighted sum of outputs. Okay. So if these both are equal, then the systems are nothing but linear systems, because they are obeying the principle of superposition and homogeneity. They are obeying the principle of superposition and homogeneity. Okay. If they does not obey the principle of superposition and homogeneity, then they are called as non-linear. When they does not obey this, simply if T of A1 x1 of n plus A2 x2 of n, that is the output due to weighted sum of inputs is not equal to weighted sum of outputs, that is A1 y1 of n plus A2 y2 of n. So it is not equal to, then we can say that if it is not equal to, then we can say that non-linear systems. We can say that non-linear systems. Okay. So the condition is this one is an input for the system, then this should be output of that system. So that is the condition. For a system, if A1 x1 of n plus A2 x2 of n is the input, then the output of the system is A1 y1 of n plus A2 y2 of n. That is, if the system obeys the above condition, or simply the transformed version of A1 of x1 of n plus A2 x2 of n is equal to A1 y1 of n plus A2 y2 of n, if then the system is called as linear system. That is, if the system obeys the above condition, if it obeys this condition, then you can call that system as a linear system. And if the system does not obey the above condition, so if it is not obeying this condition, okay, so transformed version of A1 x1 of n plus A2 x2 of n is not equal to A1 y1 of n plus A2 y2 of n, then we can say the system is a non-linear system. So if it is said to be the linear, that should be equal to. If it is said to be non-linear, that should be not equal to. So this is regarding the discrete time system. So we can take the examples also. For examples, the procedure is same what I explained for continuous time signals. So in that continuous time, what I explained, I consider the system equation y of t equal to something x square of t, and then y of t can be written as transformed version of x of t, and then for input x1 of t, what is the output y1 of t according to the given system, and what for input x2 of t, what is the output y2 of t according to the given system equation. Okay, then I find out the weighted sum of outputs, and then I go on for the output due to weighted sum of inputs, and I calculate, but if both are equal, then that is linear. If both are not equal, then that is a non-linear. So the same procedure is for this one also. The same procedure is applicable for our so for that, check whether the following systems are linear or not. So this is for your work. You have to check whether the following systems are linear or not, because I explained the concepts of how to check whether the signal is linear or not. I explained how to check whether the signal is linear or not. So how to check? We have to calculate. What is the procedure for this one? For continuous time or discrete time, the only procedure is first we have to consider the system equation. Y of t is this one or y of n is equal. Next, what I have to do? So after considering this, we can write this y of n is the transformed version of x of n, which is equal to this one. Now for input x1 of n, what is the output? y1 of n. And for the input, see, so first we have to write y of n is the transformed version of x of n, and the same thing. Next, for the input x1 of n, what is the output? y1 of n. For the input x2 of n, what is the output? y2 of n. Now weighted sum of outputs, a1 y1 of n plus a2 y2 of n. Find out these values, and then output due to weighted sum of inputs. Output due to weighted sum of transformed version of a1 x1 of n plus a2 x2 of n. Find out these values. If these two values are same, then we can say that is linear. If these two values are different, then we can say that is non-linear. Okay, non-linear. So this is the procedure to check whether the following system is linear or not. So this is for your practice. You can do it. You can do by your own. Okay, I already explained the procedure. Okay. Now I will go for the summary. Of the class what I explained today. Okay. So summary. Coming to the summary class. Yeah. So in this class what I explained? So I explained starting with non-linear systems. Non-linear systems. What is a non-linear system and how we will find out whether the system is non-linear. Okay, what is the procedure for that one and what are the equations for that one. So which condition it has to satisfy, which principles it has to satisfy, or which principles it does not satisfy to be non-linear. So I explained regarding the concept of non-linear first thing, and then I had taken an example. That is system equation for clearly understanding the concept of non-linear. So to understand the non-linear concept, I had taken an example. And I proved that system is a non-linear system, and I explained the procedure thoroughly. Okay, now so here I go for the procedure to prove that the system is non-linear, and then I explained the concept of linear and non-linear. Linear and non-linear systems with respect to discrete time. So then I explained the concept of linear and non-linear systems with respect to discrete time. So with diagrams and equations, I explained the concept of linear and non-linear systems of discrete time. Finally, I had given some problems for your practice to check whether the given signals are linear or non-linear. So I explained the procedure how to check, and I asked you to do for your practice. So this is the summary of today's class. Thank you one and all.